Guys, it's Peach here from CompSci 210, and I am here to present to you my personal project. So I am a physics and computer science major, and in particular, I'm really interested in quantum computing. So I made my project about qubits, and in particular, I made a qubit simulator. So what is a qubit? Briefly, a qubit is an arbitrary number of states in superposition with each other. So let's break that down a little bit. What's a state? A state is a two-dimensional complex vector. So a two-dimensional vector, we've all seen those before. Those can be represented on a unit circle. When you add a complex phase to that, it just adds a third dimension because you have now an imaginary part. So this plus 0.58i, that's the imaginary part of the complex number. So this just adds an extra phase to it. And this is represented in this sphere up here called a Bloch sphere, which represents each vector here represents a single state. Now, I'm in a superposition of states, and that means that I'm in none of these states until I measure it. When I measure it, my wave function or my particle will collapse into one of these states with a probability dependent on the magnitude of the state. So if I measure my qubit, it collapsed into this state with which I had a probability of getting with a 60% chance. So that was my state, but hang on, these numbers are a little bit different. What's up with that? Well, in quantum mechanics, everything needs to be normalized. That means that probabilities have to add up to 1. You can't have a 200% chance of getting a certain state. So my program is just normalizing my states on the fly. So another interesting part of quantum mechanics is that I can enter a gate. So a gate is a Hermitian matrix, Hermitian unitary matrix, and all that means is that my eigenvalues are going to be real numbers, they're not going to be complex. So this is a special gate, it's called the poly Z matrix, and what this gate means is that it represents the Z axis here. And so if I measure with this gate, I would be measuring along the z-axis. So I would be measuring in either the positive direction or the negative direction. And what am I measuring? I'm measuring the spin of the particle. So you might have heard the word spin before in chemistry or physics classes. Spin is an intrinsic part of a particle, and it can be upspin or downspin. So let's just try measuring it and see what we get. So I measure a +1 with 86.21% chance. So that means that I'd have an 86% chance of getting upspin if I measured this qubit. And of course, I can also measure it in the negative direction, which is downspin. And I can measure the expectation value or the average value of spin I would get if I measured this 1,000,000 times. Finally, I can transform my qubit, which just multiplies all the states with this gate. So that was my project in a nutshell. I had a lot of fun making it, and I hope you enjoyed watching it.